Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about permutations with repetitions, examples on numbers. In our last class, we have done some examples on numbers using repetitions. Please watch that class and come back here. The link for the playlist is provided in the description below. Coming to today's class, our explanation here is completely based on the assumption you already have the previous class knowledge. The link for the playlist is provided in the description. Coming to here, 2, 3, 6, 6, 7. These are the numbers we have, these are the digits we have taken, and from these digits we need to find the number of possibilities, means how many numbers you are going to find using these digits that are numbers less than 60,000. So if you want to find the numbers that are possible using 60,000, less than 60,000 means in the first position from the given digits you can place 2. If you place 2 here, whatever the numbers you place here, you are going to get a number that belongs to 20,000 and 30,000. If you place 3 in the first digit, you are going to get numbers that belongs to 30,000 and 40,000. So these are the possibilities we are having if you want to get numbers that are less than 60,000. So either you can place 2 or 3. But one thing you have to understand here, 2 it is not repeated here, 3 it is not repeated here. So both repetition is not there. So in order to fill the first position, how many chances are there? 2 chances are there. If the numbers are repeated, you have to do it separately. We'll get that examples later on in this video. So 2, 3, both they are not having repetitions, so you can place the first position in two ways. So 2 multiplied by, once you place the position with 2 or 3, the remaining 4 positions can be filled in. Suppose assume that if you place 2 in the first position, what are the remaining numbers? 3, 6, 6, 7. 4 digits can be filled in 4 positions, but repetition is there, 6, 6. That can be done in 4 factorial by 2 factorial. So our output is 2 multiplied by 4 factorial by 2 factorial. These many numbers we are going to get in order to that are less than 60,000. Coming to the second example, similar example, but you are having repetition separate case. Numbers less than 70,000. If you want to get the numbers that are less than 70,000 means you can place 2 here, you can place 3 here, you can place 6 here. Even though 6 is available 2 times, you have to place only 1 time because both are same. 6, 6, whatever you place, it won't affect. So the first position can be filled in with 3 numbers, 2, 3 and 6. But 6 is a separate case, because 6 is having repetitions. So do it separately. So in order to do that, if you place 2 here, remaining 4 positions can be filled with 3, 6, 6, 7. 4 factorial by 2 factorial because of repetition, 6 is repeated. If you place 3 in this position, so 2, 6, 6, 7, 4 digits can be placed in 4 positions, 4 factorial by 2 factorial. If you place 6 in the first position, remaining digits are 2, 3, 1, 6, 7. So the 4 digits can be filled in 4 positions, but repetition is not there. So if you place 6 in the first digit, the number of possibilities is just 4 factorial. So each case separately we have done, add all of them. Why addition? Because each are separate cases, they are not overlapping. So that's why either this happens or this happens or this happens. Then we go with addition. So 4 factorial by 2 factorial plus 4 factorial by 2 factorial plus 4 factorial. These are the possible numbers, these are the possible count of numbers that are less than 70,000. Coming to the last one, you need to find the numbers that are divisible by 4. In our aptitude class, in our aptitude playlist, we clearly discussed. So if you want to find the given number is divisible by 4 or not, the easy method is, see, let's 2, 3, 6, 6, 7. From this 5 digits, you can place 2 digits here. In the last 2 digits, you can place 3 and 2, means 32. If the last 2 digits, 32, is divisible by 4, then whatever you place in these positions, the entire number is going to be divisible by 4. This is the simple logic which we discussed in our aptitude playlist. So now our logic is, from the given numbers, you need to find what are the possible 2 digits that are divisible by 4. So the 2 digits that are divisible by 4 is 32 is divisible by 4. Once you place 32 here, 3 and 2 here, remaining bits are 3 bits are there, 6, 6, 7. 6, 6, 6, 6, 6, 7 can be placed in 3 positions. Repetition is there. It can be placed in 3 factorial by 2 factorial ways. The second possibility is 36. 1 6 is placing here. In the remaining 3 bits, we don't have repetition. That's why if 36 is divisible by 4. So if you place 36 in the first 2 bits position, so we are having 3 factorial ways. Similarly, we are having 72. 72 is divisible by 4. Once you place 72 in the first 2 bits position, remaining 3 bits can be placed with 366. Repetition is there. So 3 factorial by 2 factorial. Same way, 76 is also divisible by 4. If you place 76 here, remaining bits are 236. 3 factorial ways. Repetition is not there in the remaining positions. So total possibilities are 3 factorial by 2 factorial plus 3 factorial plus 3 factorial by 2 factorial plus 3 factorial. These are all the this is the count of number of digits that are divisible by 4. Hope you understand examples on numbers. This is how you are going to get examples in your exams. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.